Dear 12 month A students, I'm just quickly recording a video to answer all the questions that I had through my email from today's lesson. So in numerical order, I'll be answering question 5. I was asked for 9 part 2, but I might do the whole of 9. Question 10, question 13, and I'll have a brief discussion on question 14. So thank you for the 3 people who have asked me questions today, and I hope that this helps. So question 5, first of all, is asking for pairs of straight lines with the following gradients on a single set of axes. I'm hoping that for this one here, most of you are able to recall exactly what the gradient means and how to sketch the straight lines with those two different gradients. And some of you might also recall that this is kind of a question asking if you recognize the concept of perpendicular lines. So first of all, a line with a gradient of a third means that it will go up. So I'm just going to have them meet at the origin. It will go up by a rise of 1 to every run of 3. So if I go along 1, 2, 3, I'll go up 1. 1, 2, 3, I'll go up 1. And you should eventually find that you end up with a whole series of points that you can connect with a straight line. So it won't be quite that 45-degree diagonal, it'll be a bit flatter because it has a lower gradient. A gradient of -3 though means that the rise is 3 and the run is 1, but it is a negative gradient. So if you go backwards 1, you go up 3, which means it'll be up like that. Backwards 1, up 3. And this you should find is much steeper. So there's my gradient -3. There, and it obviously goes on to infinity in both directions. And this question's kind of getting at the idea that m1 times m2 is equal to -1 if two lines are perpendicular, which means that 1/3 times -3 is indeed equal to -1, and these two lines are perpendicular, which means they make a right angle. Question 9. So obviously you can pause and go back and look at question 5 again if you want. Question 9. For the following line, find the gradient and y-intercept, and then sketch each line using the gradient and y-intercept. So, first of all, I'll do them both as just part A and then part B. Part A, the gradient, m, is 3/4, and the y-intercept is 2, and that means that my function, my set of axes is there, passes through this point here, which is 2, and has a gradient of 3/4. So for every 3 I go along, for every 4 I go along, I go up by 3. And notice here that this gradient is not quite 1, it's not quite 1 to 1, it's 1 across to 3/4 up, 1 across to 3/4 up, 1 across to 3/4 up, so on and so forth. And obviously you would be a little bit neater than me. And there's my gradient. Part B, I have 5x minus 2y is equal to 10. I've actually written this down because they've made it a little bit harder here because we have to rearrange the equation first. So I get -2y equals -5x plus 10. So I've subtracted 5x from both sides of my equation. Now I divide by -2, and I end up with y is equal to 5/2x, because the negatives cancel, and then minus 5. So I have an m value of 5/2, or 2.5, 2.5, and a y-intercept of -5. So in this case, my function will look a little bit like this. It has a y-intercept of -5, which is here, and a gradient of 5/2. For every 2 I go along, or for every 1 I go along, I go up 2.5. 1 I go along, I go up 2.5, or for every 2 I go along, I go up 5. And there's my function there. That was a bit off track, but that's alright. and you'll obviously use a ruler and be a bit neater than me. So that's question 9, part A and B. Just remember to do the little things like label your axes and be neat and tidy. Question 10. Find the equation of a line 10A whose gradient is equal to 3 and passes through the point 2, 1. So our line always has the equation mx plus c. That's a standard linear function in gradient y-intercept form. So in this case, I know the gradient, so I can put that straight in. Y equals 3x plus c. I don't know the y-intercept though, but I do know that at x equals 2, y equals -1, which means I can put -1 equals 3 times 2 plus c into my function. -1 equals 6 plus c, and therefore c is equal to -7 if I subtract 6 from both sides. And therefore y is now equal to 3x minus 7. I'll just put that minus 7 into my function for c. And that answers my question. Question B, which passes through 2 points. So the 2 points are 1, -2 and 3, 5. Again, the easiest way to do this, I don't know the gradient or the y-intercept, is to calculate the gradient using rise over run. I could sketch the diagram and do that, or I can use this function here, y2 minus y1 over x2 minus x1, and that's equal to 5 minus -2 over 3 minus 1, and that is equal to 7 over 2, or 3.5. Okay, and so now my linear function is y equals 3.5x plus c. I can use 3.5 because it's an exact value. If my 7 over 2 was actually going to give me a decimal I'd need to round, I'd probably prefer to stick with 7 over 2. And then I substitute in at x equals 1, y equals -2, and I get -2 is equal to 3.5x plus c. So 3.5 times 1 plus c, which gives me -2 equals 3.5 plus c, and c equals -5.5. And so therefore y is equal to 3.5x plus, minus 5.5. Okay, so that is my part B. And then of course part C, which is slightly different again, whose x-intercept is 3 and y-intercept is 2. And so I might just slide across here because I'm going to run out of space below and do this. So question C, y equals mx plus c, and in the function y equals mx plus c, I'm told that the y-intercept, which is c, is equal to 2, so I have y equals mx plus 2, and I'm told that the x-intercept is equal to 3, and that is this point here, 3, 0. X-intercept is when y equals 0, and so I get 0 equals m times 3 plus 2, which means that 3m is equal to -2, m is equal to -2/3, and therefore y is equal to -2/3 x plus 2. So there's answers to A, B and C. Moving on down to question 13. A school camp consisting of 60 students, sailing was offered as an activity one morning, bushwalking in the afternoon. Every student attended at least one activity and 32 students went sailing, 40 students went bushwalking. Find the probability of the student chosen at random, etc. So this is a Venn diagram question because they could go bushwalking and sailing at the same time. But notice there is no neither because it says here that every student attended at least one activity. So in this Venn diagram, I've got bushwalking and sailing, but no student did neither. There are 60 students in total, and I'm told of the 60 students, 32 went sailing. So this circle has 32 in it, and 40 students went bushwalking. So this circle has 40. So what I'm going to do is I'm going to start with my unknown here. I'm going to call it x. And because that's x, I know that this is 40 minus x. And because that's 40 minus, well, because this is x, I also know that this is 32 minus x. And I know that 40 minus x plus 32 minus x plus 0 has to be all of my students, which is 60. And so I get 72 minus 2x plus x equals 60. So it's 72 minus x equals 60, which means that minus x equals minus 12 and x equals 12. Now, that's a reasonably complex algebraic method. Of course, you may choose to approach this being a little bit more logical and having a think about what numbers could exist, how that x could work, etc. And you're welcome to do that. But this method will work every time, and if you can do it, it's quite easy. So that means that x is 12, which means that this is 20, and this is 28, just doing those subtractions. And 28 plus 12 plus 20 gives me my 60 that I was hoping for. And then the rest is pretty easy. A undertook neither of these activities, so chosen at random, student undertook neither is 0 out of 60. B has sailed or bushwalked, so they've done one of them. And in this case, it doesn't say but not both, so therefore that's 60 out of 60. And that equals 1, that's definite. C has sailed and bushwalked, so that's both. 12 out of 60, which is 1/5. And D has sailed but not bushwalked. So 20 students sailed but didn't bushwalk, so it's 20 out of 60, which equals 1/3.